This is Dr. Mitch Robinson, and this video is on dietary components and nutrition, and it accompanies handout number 2 for cellular and molecular medicine. In this video, we'll survey the basic nutritional requirements for energy production, and we'll look more closely at specific vitamins and coenzymes that are important in the production of metabolic energy. Let's begin by looking at a requirement for energy and the basic things that we need in the diet to generate energy. And we derive energy from the food we eat, and we use that to do work. The energy we expend can be divided into 3 components, and these are shown on the bottom of page 1. The first of these is obligatory energy expenditure. This used to be called basal metabolic rate, and it is the energy we use when completely at rest to maintain our basic metabolism. And this involves things such as ion transport, protein synthesis, and basic functions such as breathing. And this component stays fairly constant. The second component is physical activity, movement or muscular work, and this is variable. So, we can increase our energy consumption, and we can lose weight by increasing our physical activity. The third component of energy expenditure is adaptive thermogenesis. That's energy that's used that changes in response to different conditions. For example, when it's cold, our bodies produce more heat. And when we fast, our bodies respond by conserving energy. And this is a big problem when we diet in order to lose weight. Our bodies respond to weight loss by conserving energy, so the more you diet, the more difficult it is to lose weight. Now, the table on page 2 lists the basic components of the diet that provide energy. These are known as macronutrients, and it gives their energy content. Carbohydrates are the largest part of our diet, and the energy yield is about 4 calories per gram. Protein has the same energy density as carbohydrate, and fat is much more energy dense, and you can get about 9 calories per gram of fat. Alcohol is not a macronutrient, but it produces 7 calories per gram. Remember these values because we'll be doing some calculation using them. Now let's look at exactly what is essential in our diet in order to maintain good health. We're interested in the various chemical components of the diet and how they are used by the body. First, let's look at macronutrients. We know that we need carbohydrates, proteins, and fats for energy production, but do we need them for other specific purposes in metabolism? Proteins are required in the diet for 2 reasons. The first is to provide a source of essential amino acids, and the second is to provide nitrogen. There are 9 essential amino acids shown on your handout, and we cannot synthesize these. Dr. Johnson will talk more about these in detail later in his part of the course. You don't have to memorize these for now. We lose nitrogen through urine and other waste products, and so we have to replace it in order to maintain nitrogen balance. Protein is the main source of nitrogen in the diet. We need about 10 to 35% of our energy to come from protein, or about 50 grams of protein a day to maintain nitrogen balance. Carbohydrates are an important source of fuel, but there's no specific requirement for carbohydrates in the diet. That is, there is no specific carbohydrate molecules that we need because we can't synthesize them. However, we do need carbohydrates as a source of energy, and it's been shown that diets that are very low in carbohydrates have some adverse effects. The current recommendation is to have about half of the energy we use supplied by carbohydrates. Fat is required in the diet as a source of essential fatty acids. Dr. Usenall will talk more about fatty acids, but I'll just point out that there are 2 types of fatty acids that are required, N-6 and N-3 fatty acids, otherwise known as omega-6 and omega-3. And these are polyunsaturated fatty acids, meaning they have 2 or more double bonds. The nomenclature describes the location of the double bond from the end of the molecule. Fatty acids have 2 ends, a carboxyl and a methyl end, and so the methyl end is considered the tail or end of the molecule. So N-3 fatty acids have a double bond, 3 carbons from the end of the molecule. N-6 fatty acids are rich in meat and vegetable oils. N-3 are present in fish and in some plants. We use these fatty acids to make eicosanoids, and these are molecules such as prostaglandins, leukotriene that act as messenger molecules. Dr. Rusino will talk more about that later. It's recommended that about 25 to 30% of the calories in the diet come from fat. And I should point out that the quality of macronutrients is as important as their quantity. We benefit from a diet that has fat high in polyunsaturated fatty acids, and we benefit if the protein has a lot of essential amino acids. Fiber is also considered an essential nutrient. We've talked about cellulose, and there are other non-digestible components of food such as lignin, and these together make up fiber, and it's important to have healthy lipid metabolism and to support good digestion. In addition to macronutrients, there are micronutrients that we need in small amounts, and these include the vitamins and minerals. Vitamins are compounds that we need but can't synthesize, and they're listed on page 3. And this includes water-soluble and fat-soluble vitamins. And you don't need to memorize this list at this point. We're going to look at these compounds all throughout the course. So you should be familiar with all the vitamins and how they work by the end of the course. There are also quite a few minerals that are required in the diet, and we'll look at these also throughout the course. Okay, now let's take a look at 4 vitamins that are important in energy production. And these vitamins are required in order to make coenzymes and cofactors, as Dr. Johnson talked about. Coenzymes are chemical compounds that are used by enzymes or proteins to carry out their activity. There's a number of reactions that cannot be performed by enzymes just using the amino acids. So they require very specific molecules that we cannot synthesize in the diet. Coenzymes can be tightly or covalently attached to an enzyme, or they may bind very loosely. And some of them actually move between enzymes, and these are sometimes called co-substrates. Okay, we want to look at 4 vitamins: thiamine, riboflavin, niacin, and pantothenic acid, and this is vitamin B1, B2, B3, and B5. By the way, there is no vitamin B4. Thiamine, or vitamin B1, is required in the diet in order to make coenzyme thiamine pyrophosphate. This part of the molecule shown here is thiamine, and phosphates are added to make thiamine pyrophosphate. The function of thiamine pyrophosphate is in the transfer of carbon groups. Now the carbon shown here in the thiazole ring can react with carbon groups to form a covalent bond, and so this coenzyme functions to transfer these carbon groups from one molecule to another. We'll look more specifically at this later and look at a specific reaction example. Thiamine pyrophosphate is used by enzymes in carbohydrate metabolism, so a deficiency results in an inability to generate energy specifically from carbohydrates. Thiamine deficiency can result in the disease beriberi. The bran portion of grain is a good source of thiamine, and this disease is usually observed where people eat a lot of polished rice that's had the bran removed. The symptoms of beriberi include weakness, weight loss, and eventually convulsions and tachycardia or rapid heartbeat. In the U.S., the most and more developed countries, thiamine deficiency is seen more often as Wernicke-Korsakoff syndrome. And this is most often found in chronic alcoholics who've had a very restricted diet. Symptoms are confusion, nystagmus or involuntary eye movement, and ataxia or lack of muscle coordination. Niacin, or vitamin B3, is also known as nicotinic acid. This vitamin is needed to make the coenzyme nicotinamide adenine dinucleotide, or NAD. This part of the molecule is niacin, or nicotinamide. A carboxyl here would be nicotinic acid. So if we have this in the diet, we can add ribose, phosphates, and adenosine to make NAD. This hydroxyl group can have a phosphate added to it, and this makes a similar coenzyme called nicotinamide adenine dinucleotide phosphate, or NADP. Both NAD and NADP serve as electron carriers. The thiazole ring shown here is in the oxidized form. In other words, it is without added electrons, and shown here in the reduced form. When we talk about carrying electrons, this also involves usually carrying protons. Now recall that a proton and an electron give you a hydrogen atom. And in metabolism, we often need to move around pairs of electrons, and we often do that as moving hydrogen atoms. So let's say we have a substrate here, RH2, that can lose 2 hydrogen, and NAD in the oxidized form can act as an acceptor. In the oxidized form, NAD is usually shown with a plus sign because it has a positive charge, and so we abbreviate it NAD+. So when we move 2 hydrogens, we're moving 2 protons and 2 electrons, and in this reaction, 1 proton stays in solution, and NAD+ accepts 2 electrons and a proton. So you end up with NADH plus a proton that's free in solution. Coenzyme NADP carries electrons in the same way as NAD, but cells use those electrons in much different way. So NADP is a way of carrying out an electron transfer, but for different uses than NAD. NADH in the reduced form is a carrier of electrons that are generally used for energy production, and NADP electrons are most often used for biosynthetic reactions. We need these electrons to make new bonds to synthesize large molecules. A deficiency in niacin results in the condition known as pellagra. Skin lesions are the most common sign of this sort of deficiency, and often this is seen as a ring around the neck. Diarrhea, dermatitis, and dementia are the usual signs of pellagra, so remember the 3 Ds. Niacin has another interesting activity. It's often prescribed to improve serum cholesterol. Taking niacin decreases VLDL, or bad cholesterol, and increases HDL, or good cholesterol. Now this effect requires a much higher dose than required to synthesize the coenzymes. It takes 2 to 6 grams a day, but it does improve cholesterol. And this is compared to a few milligrams a day for the vitamin requirement. So the dose is much different, and this is obviously a very different mechanism, and one that's not clearly understood. One of the side effects of taking this much of niacin is that it produces a flushing reaction. The skin turns red, and it's maybe burning and itching. It just lasts for about 10 to 15 minutes. Okay, riboflavin, also known as vitamin B2, is the precursor for coenzymes flavin mononucleotide and flavin adenine dinucleotide, abbreviated FMN and FAD. The structure of riboflavin is shown here, and if you add a phosphate group, you now have flavin mononucleotide. Another phosphate and an adenine, and you get flavin adenine dinucleotide, or FAD. Both FAD and FMN are carriers of electrons. FAD can accept 2 electrons and 2 protons, or 2 hydrogens. And this shows a typical reaction in which FAD carries electrons, and we have a reduced substrate and an oxidized FAD, and the hydrogens can be transferred from the substrate to form reduced FADH2. Riboflavin deficiency produces dermatitis and other symptoms, but this is a rare situation because riboflavin is so common in the diet. You rarely see riboflavin deficiency. Pantothenic acid is required in the diet for the synthesis of coenzyme A. So this part of the molecule is pantothenic acid, and if we have that in the diet, we can form this, which is coenzyme A. And again, notice that we have similar additions to the molecule, phosphates and adenosine. But in this case, we also have a thiol group. The sulfur here is the important part of the molecule because that sulfur can react with a carboxyl group to form a thioester. Now, coenzyme A is a carrier of acyl groups, And this includes molecules which have a carboxyl group and either a short or a long carbon chain. So it includes things such as acetate, 2-carbon acetate, or fatty acids. And you'll often see coenzyme A abbreviated in this way, CoA, or CoA with the SH to point out the sulfhydryl group at the end of the molecule. So when you see CoASH, that's not coash, that's coenzyme A. The term pantothenic acid comes from the Greek word pantothen, meaning from everywhere. And small amounts of pantothenic acid are found in almost every food. So you rarely see a deficiency in pantothenic acid. So that completes the video on dietary components and nutrition.